let's say that you know your probability of making a free throw. You know that the probability, and let's say the probability of scoring a free throw, just because if I say make and miss, they both start with M and it'll get confusing. So let's say the probability of scoring a free throw is going to be, let's say 70%, if we want to write it as a percent, or we could write it as 0.7 if we write it as a decimal. And let's say the probability of missing a free throw then, and this is just going to come straight out of what we just wrote down. So the probability of missing a free throw is just going to be 100% minus this. You're either going to make or miss. You're either going to score or miss. I don't want to use make and miss because they both start with M. So this is going to be a 30% probability, or if we write it as a decimal, 0.3. 1 minus 0.7. These are the only two possibilities, so they have to add up to 100%, or they have to add up to 1. Now let's say that you are going to take 6 attempts. And what we're curious about is the probability of exactly 2 scores in 6 attempts. In six attempts. So let's think about what that is. And I encourage you, if you get inspired at any point in this video, you should pause it and you should try to work through what we're asking right now. So this is what we want to figure out. The probability of exactly 2 scores in 6 attempts. So let's think about the particular ways of getting 2 scores in 6 attempts, and think about the probability for any one of those particular ways, and then we can think about how many ways can we get 2 scores in 6 attempts. So for example, you could make the first 2 free throws. So it could be score, and then you miss the next 4. So score, and then it's miss, and miss. So what's the probability of this exact thing happening? Well, you have a 0.7 chance of scoring on the first one. Then you have a 0.7 chance of scoring on the second one. And then you have a 0.3 chance of missing the next 4. So the probability of this exact circumstance is going to be what I'm writing down. And hopefully you don't get the multiplication symbols confused with the decimals. I'm trying to write them a little bit higher. So times 0.3. And what is this going to be equal to? Well, this is going to be equal to 0.7 squared times 0.3 times 0.3 to the 1, 2, 3, 4th to the 4th power. Now, is this the only way to get 2 scores in 6 attempts? No, there's many ways of getting 2 scores in 6 attempts. For example, maybe you miss the first attempt, and then you make the second attempt, you score. Then you miss the third attempt, and then let's say you make the 4th attempt, and then you miss the next 2. So then you miss and you miss. This is another way to get 2 scores in 6 attempts. And what's the probability of this happening? Well, as we'll see, it's going to be exactly this. It's just we're multiplying in different order. This is going to be 0.3 times 0.7. You have a 30% chance of missing the first one, a 70% chance of making the second one, and then times 0.3, 30% chance of missing the third, times a 70% chance of making the 4th, times a 30% chance for each of the next 2 misses. If you wanted this exact circumstance, this is once again going to be 0.7. If you just rearrange the order in which you're multiplying, this is going to be 0.7 squared times 0.3 to the 4th power. So for any one of these particular ways to get exactly 2 scores in 6 attempts, the probability is going to be this. So the probability of getting exactly 2 scores in 6 attempts, well, it's going to be any one of these probabilities times the number of ways you can get 6 scores, times the number of ways you can get 2 scores in 6 attempts. Well, if you have out of 6 attempts, you're choosing 2 of them to have scores. How many ways are there? Well, as you could imagine, this is a combinatorics problem. So you could write this as, and let me see how I could, you're going to take 6 attempts. So you could write this as 6 choose, or we're trying to, if you're picking from 6 things, your 6 attempts, and you're picking 2 of them, or 2 of them are going to be need to be made if we want to meet these circumstances. This is going to tell us the number of different ways you can make 2 scores in 6 attempts. And of course, we can write this in kind of the binomial coefficient notation. We could write this as 6 choose 2. 6 choose 2. And we could just apply the formula for combinations. So, and if this looks completely unfamiliar, I encourage you to look up combinations on Khan Academy, and we go into some detail on the reasoning behind this formula. It actually makes a lot of sense. This is going to be equal to 6 factorial over 2 factorial times 6 minus 2 factorial. So 6 minus 2 factorial. I'll do the factorial in green again. 6 minus 2 factorial. And what's this going to be equal to? This is going to be equal to 6 times 5 times 4 times 3 times 2, and I'll just throw in the 1 there, although it doesn't change the value, over 2 times 1, over 2 times 1, and 6 minus 2 is 4, so that's going to be 4 factorial. So this right over here is 4 factorial. So times 4 times 3 times 2 times 1. Well, that and that is going to cancel. And then, let's see, 6 divided by 2 is 3. So this is 15. There's 15 different ways that you could pick 2 things out of 6, I guess is one way to say it. Or there's 15, did I say 16? No, there's 15, the 6's and the 5's. There's 15 different ways that you could pick 2 things out of 6. Or another way of thinking about it is there's 15 different ways to make 2 out of 6 free throws. Now, the probability for each of those is this right over here. So the probability of exactly 2 scores in 6 attempts, well, this is where we deserve a little bit of a drum roll. This is going to be 6 choose 2 times 0.7 squared. This is 2, you're going to make 2, and then it's 0.3 to the 0.3 to the 4th power. Notice these will necessarily add up to 6. So if this right over here was a 3, then this right over here would be a 3, and then this would be 6 minus 3, or 3 right over here. And now what is this value? Well, it's going to be equal to, we have our 15, 3 times 5. So we have this business right over here. It's going to be 15 times, let's see, in yellow, 0.7 times 0.7 is going to be times 0.49. And let's see, 3 to the 4th power would be 81. 3 to the 4th power would be 81. But I'm multiplying 4 decimals. Each of them have 1 space to the right of the decimal point. So I'm going to have, I'm going to have 4 spaces to the right of the decimal. So 0.0081. So there you go. Whatever this number is, and actually I might as well get a calculator out and calculate it. So this is going to be, so it's 15 times 0.49 times 0.0081, and we get 0.59535. So this is going to be equal to, let me write it down. And actually maybe I wish I had a little bit more real estate right over here, but I'll write it in a very bold color. This is going to be, actually I'm kind of out of bold colors. I'll write it in a slightly less bold color. This is going to be equal to 0.05935 if we wanted the exact number. Or we could say this is approximately, if we round to the nearest percentage, this is approximately a 6% chance, 6% probability of getting exactly 2 scores in the 6 attempts. I didn't say 2 or more. I just said exactly 2 scores in the 6 attempts. And actually, it's a fairly low probability because I have a pretty high free throw percentage. If someone has this high of a free throw percentage, it's actually reasonably unlikely that they're only going to make 2 scores in the 6 attempts.